Hey guys, in this next video we're going to get introduced to the concept of rational exponents. If you're savvy with your math vocabulary, you know that rational is just another vocabulary word for fraction. So we're talking about fraction exponents here in this next video. The definition of a fraction exponent, you need to know this, is if I have a exponent problem that looks like this, a to the m over n power, then that is defined as the nth root of a to the m, or the nth root of a in parentheses to the mth power. So this right here is a definition. You need to know this rule right here in order to do the problems in this lesson. So this is something that needs to be memorized here, this basic definition of what it means to be a fraction exponent. So using this definition here, I can simplify each of these problems in 1 through 9 here. Starting with number 1, 36 to the 1/2 power. So if we use the definition up here and we say that m is 1 and n is 2, okay, your numerator 1, your denominator 2, I can rewrite this as the second root. Your denominator is really your index, so the second root of 36 to the first. Okay, well, 36 to the first is just 36. The second root, we know that means square root, so really 36 to the 1/2 power is the square root of 36, which we know is just 6. So anytime you see a 1/2 power, that just means a regular square root. Take the square root of that number. 64 to the 1/3 power, using this definition, means that your index is 3, your denominator. So the cubed root of 64 to the first is what 64 to the 1/3 means. Well, we know the cubed root of 64 is 4. Based on our perfect cubes. So 64 to the 1/3 is 4. 49 to the negative 1/2 power. We need to recall what a negative exponent means. It does not mean a negative answer. Recall that negative exponents mean that you take the reciprocal of your base. So 49 to the negative 1/2 power is the same thing as 1 over 49 to the positive 1/2. Okay, we know from number 1 here that the positive 1/2 power means the same thing as a regular radical, so this is the same thing as radical, or 1 over radical 49. Radical 49 is just 7, so this becomes 1/7. Okay, number 4, same thing. I have a negative exponents. I have 1/8, this time as my base, to the negative 1/3 power. So again, that negative exponent there means that we take the reciprocal of our base. Okay, that's what a negative exponent means. It means take the reciprocal of your base. So right now my base is 1/8. The reciprocal of 1/8 is just 8. Okay, if I flip 1/8, I get 8. So 1/8 to the negative 1/3 is the same thing as 8 to the positive 1/3. 8 to the positive 1/3 can be rewritten as the cubed root of 8 to the first, and the cubed root of 8 we know is just 2. So this simplifies down to positive 2. Okay, number 5. Now I'm going to change my numerator up, and I'm going to make my numerator something besides 1. I had 36 to the 3/2 power. Well, using our definition again, your denominator is your index, so this is a second root or a square root of 36. And then I'm going to use that second way to write this. I can rewrite this as the square root of 36 to the numerator's power. My numerator here is 3. So this is the square root of 36 cubed. The reason I'm doing that is because I know what radical 36 is. Radical 36 is just 6. So this is the same thing as 6 cubed, which is 216. Okay, same thing for number 6. We have 27 to the 4/3 power. So that's the same thing as the cubed root of 27 taken to the 4th power. Well, I know the cubed root of 27 is 3, so I can rewrite this as 3 to the 4th power, which becomes 81. Okay, number 7. This time I need to remember my multiplication property when I'm multiplying powers with the same base. Okay, remember if you have something like x cubed times x squared. That's when you keep the base and add your exponents, so you'd get x to the 5th if you had a problem like this. Well, number 7, we're going to do something similar. We have 7 to the 1/2 times 7 to the 1/2. So I keep my base, which is 7, and I add my exponents. 1/2 plus 1/2 gives me 7 to the 1st. 7 to the 1st is just 7. Okay, number 8. This time I have 5 to the 1/4 times 125 to the 1/4. One strategy that we're going to employ a lot in the next couple of units is, can you rewrite bases that you're given using a smaller base as a power? Okay, so basically, can I rewrite 125 using exponents with a smaller base? And the answer is yes. 125 is the same thing as 5 cubed. So what I'm going to do is I'm going to rewrite 125 as 5 cubed. And that's going to help me a little bit for this one, because now both of my bases are the same. I've got 5 to the 1/4 over here times 5 cubed to the 1/4. And so now, using my exponent properties, you know, a power to a power, that's when you multiply your exponents. So 5 cubed to the 1/4 is the same thing as 5 to the 3/4. I just have to multiply my exponents here, 3 and 1/4. And so then I have 5 to the 1/4 times 5 to the 3/4. I keep my base, and I add my exponents now, 1/4 plus 3/4, which gives me 5 to the 1st, or just 5. Okay, number 9, I have 16 to the negative 2.5 power. So I'm going to rewrite this as 1 over 16 to the positive 2.5. 2.5 is just another way of writing the fraction 5 over 2. So this would be the same thing as 1 over 16 to the 5/2 power. And then based on our definition up at the top, 16 to the 5/2, we know we can rewrite as 1 over the square root of 16 to the 5th power. Okay, so radical 16 is 4, so this is the same thing as 1 over 4 to the 5th power, and 4 to the 5th power will give me 1024. So the answer to this one is 1 over 1024. And now taking a look at the back side, for these I'm basically just asking you to use that definition at the top to rewrite each of these expressions in radical form. So that means they should have radicals in there. So number 10, x to the 3/7 can be rewritten one of two ways, either the 7th root of x cubed or the 7th root of x quantity cubed. Okay, so either one of those would be a correct answer in radical form. Number 11, y to the 0.2 power is the same thing as y to the 1/5 power, which would be the 5th root, or excuse me, w is my variable, so w to the 1/5 or the 5th root of w. Okay, and then number 12, I have w to the negative 4/5. I can rewrite that as 1 over w to the 4/5. From there, I can make that 1 over the 5th root of w to the 4th. And we know from working with fractions and radicals for a few days that you cannot have a radical in your denominator. So now I need to rationalize my denominator. Right now I have a w to the 4th power. My index is 5. That means I want to raise this w to the next multiple of 5 power. So I need to raise it to the 5th power, meaning I'm going to multiply the denominator by the 5th root of w to the 1st in order to raise my radicand to the 5th power. And so that's what I'll do on the top as well. And so I end up getting the 5th root of w on the top over w on the bottom. Okay, any questions you have over this video, feel free to email me those, and we'll discuss those the next time I see you in class. Until then, have a nice day. You're all wonderful people. Take care.